Welcome to this recording of the PFAS MCL Rule Public Water Supplier and Operator Training. This recording will cover Lesson 3 and will provide sampling tips and considerations for avoiding cross-contamination. In this lesson, we will cover approved analytical methods for PFAS, tips to avoid cross-contamination during sampling, best practices for collecting PFAS samples from drinking water, sample QAQC, and tips for labeling samples. Keep in mind that the Pennsylvania DEP accredited laboratory that you select to perform the analysis of your PFAS samples should provide you with sample collection instructions, which may be brief. This lesson will share tips for avoiding incidental cross-contamination of PFAS in your samples. Ultimately, you should be sure to follow the instructions provided by your accredited laboratory. Remember that some of the physical properties of PFAS include that they are highly soluble in water and they are resistant to water, grease, oil, stains, and heat. It is because of these properties, and specifically because of their resistance to water, grease, oil, and heat, that PFAS have applications in many consumer and industrial products. There are currently 3 approved methods for analysis of PFAS as shown here on the slide: EPA methods 537, 537.1, and 533. These are the approved methods that are identified in the PFAS MCL regulatory language. It's critical to make sure that the selected lab will be using and is accredited for one of these methods for your PFAS analysis. The lab will provide you with the specific pre-preserved bottles required by the method prior to sampling. Take an inventory of all bottles as soon as you receive them from the lab. Immediately contact the lab to address any questions or discrepancies so that the lab has time to send the correct or missing bottles prior to your sampling event. Let's talk about sample collection. Note that sample collection is the first point at which error can be introduced into sample results. So let's look at avoiding cross-contamination and other sampling considerations. As we learned in Lesson 1, many common items contain PFAS, such as those shown here and listed in the workbook. These items could potentially be a factor during sampling. They can include stain-resistant and water-resistant clothing. New clothing that hasn't been washed several times can contain PFAS. Fabric softeners and anti-static dryer sheets can also contain PFAS. Many food wrappers are designed to be grease resistant and they can contain PFAS, so you should avoid eating a fast food burger and then collecting samples without a thorough hand washing first. We'll talk more about hand washing on the next slide. Don't forget personal care products. Some sunscreens, bug sprays, cosmetics, and other personal care products have been found to contain PFAS. It's strongly recommended to perform due diligence on your personal care products to evaluate them for PFAS content prior to your sampling event, or simply avoid any unnecessary products altogether if feasible. You should also avoid the waterproof paper that can be found in some field books and avoid waterproof markers, as these can also contain PFAS. Instead, use ballpoint pen to label bottles. The best way to avoid errant detections of PFAS in samples is to avoid anything that may contain PFAS on the day of the sampling event, at least to the extent possible. Hand washing is critical for PFAS sample collection. Samplers should wash their hands after handling any materials that may contain PFAS and before collecting each sample. Hand washing should be done with a dilute solution of a phosphate-free laboratory detergent or a plain bar soap. Rinse with PFAS-free water, such as lab-grade reagent water. Samplers should also wear nitrile gloves when collecting PFAS samples. Frequent changing of disposable nitrile gloves while collecting and handling samples is crucial in avoiding cross-contamination. Use a new pair of nitrile gloves with each and every sample. It's cheaper to change nitrile gloves frequently than to be faced with resampling because of an unexpected or unexplained detection of PFAS. Make certain that the interior of your sample cooler is clean. Use the same phosphate-free laboratory detergent solution for cleaning the inside of your sample cooler. If possible, use a cooler dedicated to PFAS sampling, or at least dedicated to drinking water samples only. With PFAS, the sampling environment is a factor to consider with avoiding cross-contamination. Compliance samples are collected at the entry point for PFAS. Entry points are the first tap of finished water in a water system, immediately following all treatment processes. Entry points can vary in character and location. They may be located in well houses or treatment buildings, but they may also be found as fire hydrants, sink faucets in kitchens, bathrooms, break rooms, or utility closets. Entry points may also be found in nearby schools, houses of worship, gated municipal property, homes, or businesses. It is recommended to record observations at the entry point sample tap location in a field notebook. Record details such as types of pipes and fittings present, the sample collection time, site characteristics, atmospheric conditions, personal notes such as whether a break was taken for food, and so on. Also, take photos to document specific conditions encountered and how the sample was collected. Record this information at the time of sampling. Sampling taps and plumbing should be free of materials containing Teflon, such as Teflon tape at plumbing joints. If these cannot be avoided, ensure the tap has been flushed for at least 5 minutes. Be sure to note the presence of Teflon materials in the field notebook. Remove aerators, screens, washers, hoses, and water filters, if present, from the tap prior to flushing. Samplers should treat every entry point tap as potentially having PFAS contamination at or surrounding the tap. Keep sample containers closed until you are ready to fill the bottle at the entry point. Use caution whenever you remove the sample bottle lids. Protect the sample bottle integrity by not touching the inside of the bottle caps or bottles once opened, and do not allow bottle caps to come into contact with surfaces that may be contaminated by PFAS. While filling sample bottles, if you think you may have inadvertently touched something at or near the sample tap that could potentially have been contaminated with PFAS, replace your gloves with clean nitrile gloves. Remember, your lab should give you specific instructions which you should be sure to follow. Use only laboratory-provided and preserved bottles for samples. This is very important because the bottles should be made of polypropylene and caps must be unlined. In other words, no Teflon-lined caps. Sample bottles that contain a preservative should be filled very carefully, as overfilling would mean that some of the preservative was lost and therefore the sample would not be properly preserved. It is highly advisable to have extra sample bottles available in case of an overfill and loss of preservative. When it comes to labeling your sample bottles, make sure all sample collection information is filled out properly and completely to ensure proper reporting to DEP. Accurate labeling of sample bottles includes carefully cross-checking all filled sample bottles with the entries on the chain of custody. All sample bottle labels should be completed and affixed to the bottles prior to sampling. There's less room for error if you already have the bottle labeled. Triple check that the correct entry point identification is on all sample bottles as soon as it's filled. Once filled with sample, bottles should be placed in a self-sealing plastic bag. Once that bag is closed, a custody seal should be placed on the bag such that the seal prevents access to the filled bottles. Some labs recommend that a second bag should be placed over the custody sealed bag such that the sample is double bagged. Use custody seals provided by the laboratory. Double bagging the samples will protect the custody seal and ensure that the filled sample bottles will not come in contact with ice or ice water in the cooler. All samples should be iced immediately after collection. This is very important. Fill the cooler with wet ice, preferably in resealable storage bags, before your departure for the sample collection event. Samples must be chilled during shipment and must not exceed 10 degrees C during the first 48 hours after collection. And ideally, you'll want to keep any meltwater from melted ice drained from the cooler to avoid soaking the sample containers. Blue ice, or the reusable chemical ice, can contain PFAS and should only be used if provided by the approved laboratory and the laboratory certifies that the chemical ice is free of PFAS compounds. Dry ice should never be used because its temperature can be several degrees less than 32 degrees Fahrenheit and thus could damage the sample bottles. Finally, we will briefly cover QAQC. The purpose of the QAQC process is to ensure a high level of confidence in the sample results. QAQC is required for all sampling events. Your lab should provide instructions for any required QAQC. Each EPA method for PFAS defines the QAQC for sample collection, preservation, shipment, and storage. One type of QAQC sample that the lab may request is a field duplicate. This is when you collect two separate samples at the same time and place and send to the lab. Another QAQ sample is the field reagent blank. Field reagent blanks, or FRBs, are collected with lab reagent water that is brought to the sampling site and poured into a separate sample bottle and then shipped back to the laboratory for analysis. Your laboratory should provide instructions for preparing the reagent blank in the field. The reagent blank is labeled and logged onto the chain of custody as the FRB. Note that FRB collection is required by all three approved analytical methods. However, FRBs do not need to be analyzed if PFAS was not detected in the entry point sample. Next, we have an activity to test your understanding. You can find activity number 2 on page 3-6 in the workbook. You may pause the recording now to work through the activity and answer the questions, and then come back to the recording. The next several slides will go over the answers to the activity. Let's review the answers for activity number 2. Question 1, which of the following may contain PFAS? The correct answer is all of them, A, B, C, D, and E. They all could contain PFAS and be a potential source of cross-contamination during sampling. Question 2, which of the following is an approved method for PFAS analysis? The correct answer is A, B, and C. These are the 3 approved methods in the PFAS MCL Rule regulatory language. As a side note, if you remembered that EPA method 334.0 is for residual chlorine analysis, great job. Question 3. What is the compliance sampling location for PFAS samples? The correct answer is B, entry point tap. Question 4. True or false, latex gloves should be changed after collecting a PFAS sample at each entry point? The correct answer is B, false. This was a bit of a tricky question because you should not use latex gloves for PFAS sampling. Use nitrile gloves only. But your nitrile gloves should be changed for each sample location. Great job if you caught that. Question 5. Which of the following are true? During sample collection, you should do what? And the correct answer is A, D, and E. Keep sample bottles closed until ready to sample. Carefully fill bottles to avoid losing preservative. And place sample bottles in a self-sealing plastic bag. That concludes Lesson 3 on sampling considerations. Let's review these key points from this lesson. The accredited lab should provide sample collection instructions. It is important to follow those instructions along with tips for avoiding inadvertent cross-contamination. Sample collection is the first point at which error can be introduced into sample results, so it is critical to use care when collecting any compliance samples. Avoiding materials that may contain PFAS on the day of sample collection may help prevent cross-contamination. And collect all QAQC samples required by the laboratory following their instructions. The next lesson in this course is Lesson 4, Compliance.